Introducing the SAFI Steel Calculator, an essential tool for design, validation, and optimization of steel beams and columns. It supports a comprehensive range of design standards from American, Canadian, and worldwide international design codes. Let's take a look at a few quick examples of beam and column design using the Steel Calculator. To walk us through it, I'll hand it over to Michael, who'll guide us through the process step by step.
These simple examples will give you a good idea of the capabilities of the SAFI Steel Calculator. In the first example, we will do a two-span, simply supported beam. First, we will select the beam model number M6. The model type is made of two continuous sections on 3 supports. Once selected, we can specify the length of the 2 different segments. The first one being 6,000 millimeters long, and the second 8,000 millimeters long. To add the loads, we can open the Uniform Loads tab at the bottom of the screen. In this tab, we will define 3 types of loads. First, a dead load of -10 kilonewtons per meter. We will then define the same load intensity for a live load and a snow load. Once the 3 uniform loads are defined, we can go ahead and close this window. We can then take a look at the different load parameters in this window. We can see which design code is used for the model, as well as the different design parameters. The load combinations are generated automatically from the design standards. The overview of all the load combinations are presented in the bottom of the window. We can see a preview of the model in this window, as well as a preview of the section used. And we can also view the preview of the loads in this menu for all loads or for a specific load type. We can now launch the verification of the default section, W1100 by 499. The limit states are presented for 2 sections of the beam separately. As we can see, the limit state for this section is very low. We can find a section that is more fitting for these loads. The purpose of the Optimize button will assist to find the most suitable section. We now have a smaller section of W310 by 74. We can see that the limit state for member number 2 is now at 98%. Several design parameters can be adjusted in the Design Parameter menu. In this example, we will adjust the unbraced length on the top flange to 2,000 millimeters. We will also set the unbraced length to 3,000 millimeters on the bottom flange. We can also set a maximum deflection parameter. We will set the service load deflection criterion to 3/60th of the length of the beam. We can open the Geometric Limit tab and set the limit on a different parameter. For this example, we will set the maximum height of the section to 400 millimeters. Once again, we can launch the verification of the section. The red symbol here shows that one of the limit states is not respected. We can use the Optimize command once again to find a suitable section. This new section is meeting all the design requirements of our model. Once the analysis is complete, we can take a look at the different results. We can see the following: the deflection criterion, the support reactions, and the reaction summary, the table for resistance, the limit state overview for each section, and finally, we can see the graphs of the internal forces for the shear and bending moment. We can also see the graph of the displacement. These results can be presented as an envelope or for each load combination separately. The Verify All command will show all the sections of the chosen type with their maximum limit state, as well as the controlling criterion for the section. The Report command will generate a printable version of all the results shown previously. The content of the report is customizable for ease of use. For column design, we can select one of the different beam model type. Once selected, the column parameters are defined in a similar way as the beams. For the design parameter, however, we can define additional parameters for compression, such as the buckling factor in both axes as well as the buckling length. Once defined, the results will be presented in the table shown previously.
Well, thanks, Michael. That was a great walkthrough. We hope you enjoyed these quick examples of the steel calculator. Ready to enhance productivity? Click the link in the video description to get started with the steel calculator today.